Basically, we're using Foursquare check-ins, which are by default private, but people can elect to share their Foursquare check-ins publicly via Twitter. And so these tweets can then be aligned with the underlying Foursquare venues using Foursquare's API. And when this is done, each datum in our data set is essentially a 6-tuple of the user ID, a timestamp, a venue ID, a latitude, longitude, and a venue category. And in this work, we're using approximately 17 million check-ins that are gathered from the entire world. I'll briefly touch on some of the technical details of the clustering methodology. I'm going to go rather fast through this because I'd like to get to some other interesting parts of this study. So in order for this approach to work, we need a similarity measure that captures the social affinity between a pair of venues. And to accomplish this, what we do is we model a venue as the bag of users that have checked into that venue. That is, we model a venue as a vector, where each component of the vector counts for a particular user the number of times that user has checked into the venue. Once we have this model in place, we can compute standard vector similarity-based measures to get a sense of the social similarity between two venues. In this work, we use cosine similarity. In order to ensure that the clusters that we find are spatially contiguous, what we need to do is blend this notion of social similarity with one of a spatial proximity. And so the approach we take is to restrict the computed social similarity measure to the m nearest by geographic distance venues for some value of m. So let me make that a little bit clearer. We can think of a graph where the nodes are the venues, and we're connecting each node to its m nearest neighbors by geographic distance. And then we're weighting the edges based off of this idea of this social similarity. And so once we have this in place,